Welcome, Algebra 1 students. Today's lesson is going to be about combining like terms. So let's get right to it. You might be asking, what is she talking about? What are like terms? And first of all, we have to decide what are terms. Okay, so notice I have an expression here. This is an expression, this whole thing right here. It's not an equation because there's no equal sign. And an expression is made up of parts. And those parts, okay, so this is a part, and this is a part, and this is a part, and this is a part. Those are all parts. Parts is parts. And those parts are called terms. So all of the little pieces in this expression are called terms. And so we have to learn what it means to combine them. So like there's some terms. And notice I'm coloring them a certain way. And as I'm coloring them, maybe you see that the colors I have something in common. Okay, so that's what we're talking about when we talk about like terms. So like terms are the parts, okay, are the parts in common that have the same characteristics. Oh, you can't read that bottom word, can you? They are the parts that are in common. Okay, so we're going to define this. You should have this written in your notebook. Okay, so write down that expression, hit pause, okay, hit pause, and write down the expression and write down everything that I just wrote down. Anything I write down is important for you to write down. So hit pause, and then we're going to move on. Okay. So this is what I call a Frayer model, and we're going to put some definition to the like terms. So we're defining what like terms are. We're going to put a definition in the upper left-hand corner. We're going to talk about some characteristics. We're going to put some examples and non-examples. So again, I want you to hit pause, and I want you to add this to your notebook. Okay. All right, so let's define. I'm going to change colors here. What does it mean to be like terms? All right, well, these are the parts of an expression okay, that have the exact same variable. Okay, so the letters or the numbers, the exact same variable parts. And what do I mean by the exact same? And if you need to, hit pause so you can write that down. Okay, so hit pause if you need to. When we talk about characteristics, okay, the variable has the same letter and exponent. Okay, so the variable has the same letter and exponent. So those are some characteristics, all right? Again, hit pause and write that down. All right, let's move on to some examples. Some examples are going to include 4x and 3x. Okay, those are parts, those are terms, and they both have an x in them. It doesn't matter what their number is, but they both have an x in them. Another example 3y squared, and 5y squared. So notice these two are like terms because they both have a y, and not only do they both have a y, but they're both y squared. Okay? So some non-examples, let's pick a different color, we'll go black. Some non-examples would be like 4x and 3. Those are not like terms, so we can't combine those. We can't bring them together. Another example would be like 3y squared and 5y, kind of from our example box. They both have a y in them, right? But the 5y isn't y squared, so we can't call those like terms. Okay, so this is a definition. I'm going to stop this video. These are the notes, and then we're going to look at some examples next.